Hey, thank you very much, Yasmina. Thank you to everyone for participating in this webcast. I appreciate the time and hope that these next few slides and the next couple minutes we're going to go over will be helpful for any sort of user authentication process that you want to do in a single page application. I will be trying to keep these slides to approximately 35 minutes. That way we have a solid 20 minutes for questions at the end. Yeah, I do recommend that if you want to follow along, you can go ahead and clone some of the code. I will be providing examples of the code in the slides, so if you just want to observe, that's fine. However, if you would like to see all the code in context, you can follow these steps here to go ahead and clone that repository and then run the necessary steps to install that dependency. Today we're going to talk mostly of 3 different ways of handling user authentication. Angular provides what we are going to call HTTP interceptors. We'll talk a little bit about how and why you might want to use them. We'll also discuss the idea of whitelisting and blacklisting routes, whether that's a single individual route or an entire path. And then finally we'll discuss a little bit about using services to share state as we move forward. Once again, I highly recommend most of this code will make far more sense in context. If you would like to go ahead and execute that, this grunt serve command will bring up a browser and ask you for a username. The only reason for that is because we are working with a real API today, and that username will serve to namespace any users you create either today or later using this code, so that if any of you both create the same user tester, for example, you won't end up with conflicting data or see a random list of users that you weren't expecting. Additionally, at any point, if you would like to follow along, again, in the bottom left, there's a tag name. The Git repo has been tagged with various stages as we go through this presentation. So you can always have the most recent and accurate copy. The last one will be on the bottom left. And then the code we'll be developing towards will be on the bottom right. So if you want to see it in context, again, go ahead and check out that tag at the bottom right. All line numbers will be relative to that tag. That way you can find it quickly when you're looking for the context. Let's go ahead and get started with HTTP interceptors. These interceptors can serve multiple purposes. They have a lot of different functionality available within Angular. But we're going to focus primarily on the top 2 here, which is the ability to transform requests and responses. Angular lets you take that data, whether it's on the way out in the form of a configuration, as far as the parameters you might be sending, the URL it's going to, or any additional headers that you want to modify. It also lets you take the response data that's returned and again modify it. It also allows you, and this is particularly important for today's discussion, to reject or allow specific API requests based on other state of your application. Obviously today we'll be discussing the state of whether or not your user is actually logged in. Interceptors do in fact allow you to also handle situations where you might want to recover from an error, whether it's the API itself has returned an error or one of your other interceptors has blocked you, rejected that request. It also allows you to simply provide better logging, whether that's something where you want to send your errors out to something like Airbreak to keep track of everything, or just provide a better and more uniform error messaging to your actual visitors. Interceptor methods allow 4 basic types of properties. The one that we're going to be focusing on most today is the request property. Again, this receives a configuration of the HTTP request, and we'll go and dive into this in significantly more detail here in a moment. The other 3, just for your own reference, are the request error. This again is if a previous request interceptor has decided that they want to reject that API request for any reason. You can choose at this point whether or not you want to re-allow a request based on some certain modifications, or simply, again, log that error out for your own information. Again, the response. This is something that I see trip up a lot of people. The HTTP library provides 2 very handy helpful methods of .success and .error that I'm sure many of you are familiar with. However, in each of those methods, all you receive back is the actual data or the body of the request. This is extremely helpful, and it's usually all you need. However, in this case, the response parameters that you receive back is not just the data, but it's actually a larger subset or a larger set of data, including both the headers to allow you to read headers off a response object, the XHR status code, as well as the data nested in under a separate property. So I would encourage you, if you're going to try to use these sort of response interceptors, to make sure you look more closely at the data you're getting back, as it's very easy to get tripped up if you assume that it's simply going to be the same type of data as you're used to receiving. Most web applications offer two basic methods of authentication. The vast majority that have been built, and you're probably most familiar with, is typical session cookie authentication. And so for today's discussion, we're going to focus on that sort of authentication in a front-end web application because that's simply the most compatible. You likely have a backend that's already built, that's already using this kind of authentication. And if you're just trying to work at decoupling your app into a front-end and a back-end API, this requires the least extra development on your back-end to be fully supportive of a front-end authenticated web app. The other most common is header-based authentication. You'll see this more commonly with third-party APIs, services where you don't want to be sending all of your users' cookies for obvious security reasons to their end request. So instead, you only specify very specific headers that you want to use for your authentication. This, again, is most flexible with third-party APIs, but is a little bit more specific to each individual API. If you do want to see an example of this, the code that we're using to interface with the user API today is, in fact, following that parameter or that methodology. And you can see an example inside. This is actually app/scripts/services.mvd.js. And you'll be able to see a version of that kind of authentication there. And if after this presentation there are some questions around that, I'd be happy to talk more about that in detail. Let's go ahead and dive into the cookie-based authentication. Don't worry about trying to read through all of this right now. I just provided as an example of the context about what we're about to talk about. You can see here that an interceptor is configured via the config block for your model or your application. We've also defined this user API URL. This is key because oftentimes I'll see when people first start to put authentication into their app, they get excited about cookies and they just authenticate every request with cookies. But obviously this is a pretty significant security issue for the sake of your users because you're now sending each user security session cookie out to every API or third-party service you're making a request to. This is obviously a bad idea. And so we'll get into how you might check that going forward. And then finally, we have this factory. This is the meat of our interceptor. You can see it's pretty simple. Most interceptors, by and large, are not actually that complicated because for two main reasons. One, they're going to be executed on every request. So you want to make sure that this is not something that's heavy or going to require a lot of processing by any means. And it also usually want to serve as just a single function. In this case, all we're doing is we're first checking to see whether or not this specific request has a bypass authorization flag. This is a custom flag that you can use within your app. You're welcome to name it whatever you want. There is no Angular specific standard for this, but I prefer bypass auth because it tells me exactly what's going on. And any HTTP request you make through the $HTTP library in Angular, that last parameter is a config block, and you can specify any data you want there that you might be using within your interceptors or just want to send along to the actual API. Excuse me. And then finally, as I just mentioned, we're checking here to make sure that this URL is in fact going to our end API URL. This is crucial before we specify this with credentials flag. Make sure that those cookies are, again, only going to our own API. In the case of cookie-based authentication, it is extremely simple. All you have to do is add this config.withCredentials=true, and that tells the browser to make sure to go ahead and send off the cookies to the final API. It is worth noting this will require some server config if you're doing any sort of cross-domain requests. You do have to specify the explicit CORS header that allows credentials to be passed. And so this does, in fact, have to be specified both on your front-end app and your server-side app. But outside of this, assuming that you're following the standard cookie methodology of your actual back-end server, this should be the only change you need to make to your server to allow these front-end applications to be fully authenticated. And then finally, you can see here at the end of the request block, all we're doing is returning the config. There's two basic options in any interceptor. You can either return the config in the case of a request, or the response data in the form of a response interceptor, or you can return some sort of promise that will, in fact, resolve to either a rejection in the case of an authentication issue, or resolve to that final config or response in the case of an approved request. Let's go ahead and talk a little bit about routing. In most web applications, there is likely going to be at least a couple routes that you want to whitelist to be able to allow any user or non-authenticated visitor to access. However, most of the time, especially as you're adding new features or adding new views and settings, the vast majority of your new development is in fact going to require authentication. So when we're talking about web apps, I prefer to use the whitelisting approach for which routes don't require authentication, as opposed to doing something that requires me to blacklist every new route as I create it going forward. Secondly, each individual route should either be able to bypass its authentication check. This is something we saw a few slides ago with regard to the bypass auth flag. This is what allows us to say, for example, when you're loading a user, it doesn't matter which route you're on. You want to be able to check and see if a user does in fact exist based on any cookies or existing authentication values. So that's a perfect example of the type of request where you want to bypass that authentication requirement every single time. And then finally, this is important to note, particularly if you are used to either being some sort of backend developer or full stack where you only have to check that authentication once and you're covered. Do remember you're working on front-end code here. It is entirely possible that your user can fire up Chrome Web Tools, open up the file that you're working with, and rewrite the entire thing if they want to. So all of these security issues that we're talking about today are really designed for the end user experience, for the visitors who are actually interested in using your app and not trying to hack you. So we want to make sure that for those users, we provide the best experience possible. But of course, any request that does in fact make it to the API still is authenticated again. We'll cover this in a second. So let's talk about the two main methods we're going to use inside our interceptor to validate whether or not our user is authenticated. This is a simple isAuthorized request. I'm not going to dive into what exactly is going on inside this request because it's likely going to change for you every time you write a new web app. It could be a roles-based web authentication. It could be just a simple binary logged in or logged not. But the main aim here is to take advantage of a service that is going to share our state across every page load, across every new route. One of the things I see a lot and did a lot myself as I first started building Angular applications is a tendency to assume that if Route A and Route B use the same controller, then surely when we navigate, everything I've initialized in the controller the first time will still be there. In fact, that's not the case. Angular will reinitialize that controller and lose any sort of state. And so particularly when you're dealing with users or groups or roles of any sort, it's highly recommended to make sure that kind of state is stored in a service because those are only initialized once for the entire web application. And unless you explicitly try to flush some of that data, it will always be there and ready for you to use, either in this case in an interceptor or inside any of your controllers. Again, this is nested inside our request interceptor. And we're basically doing two things here. First, we're checking to see if the user is in fact authorized. If they are, we're done. There's no reason we need to worry about blocking their request, and we can send it right along. After that, we go ahead and move on to have they explicitly asked us to bypass the authentication. Again, this is something for if you're loading a user to check whether or not they've actually logged in, perhaps checking a session timeout, or any sort of data that's not particular to a user authentication. And then finally, we're going to check our whitelist. This is, implementation is going to vary a lot based on your application. You're welcome, of course, to look inside the Get repo code that I've provided for a basic example of how you might implement this inside an app. But in this case here, all we want to do is check that our current path, the route that the user is on, does in fact qualify as a whitelist. One thing that's worth noting, and something that I'm reminded of, especially most of the time I'm doing interceptors, is that because you're initializing these within a configuration block, it's very easy to put yourself into circular dependencies, to find yourself needing a variety of different services that you want to require that maybe are not ready yet when you're first putting this together. And so I find, as much as I hate to use it, this is a common instance where I'm required to use something to the effect of root scope on or emit to keep track of changes. For example, in this case, I have a listener above that says on route change start, tell me what the new path they're on, so I can use that in all my checks going forward. The second primary method we're going to use here is whitelist route. This is something that is a pretty standard or very simple method. Basically, all we're doing is checking if it's a string. Assume that that's the exact string that we want to whitelist. This could be flash. This could be flash login. We'll see a couple of those examples here in a moment. Or if we want to allow you, as you're creating your application, to do some sort of regular expression-based route, we also allow that. And then for the example of the previous whitelisted method that we talked about, all it is an iteration through this array to see if one of these routes is already whitelisted and test it against that regular expression. And then for the glue of this, basically all we have to do is, again, inside our configuration block, we've provided ourselves a provider. Providers, if you've done too much Angular development, you're likely familiar mostly with factories, directives, controllers. Those are all very nicely, magically put together by Angular, and they work really well. However, when you're dealing with providers, a lot of that magic gets stripped away, and so I do invite you to take a look into some of this code. This isn't a webcast on providers, so I'm not going to dive into them too much, but I do encourage you to look at the code that goes into this user auth provider to get a better understanding of how those glue together. But the advantage of using a provider is it lets us access some of these methods, again, inside the configuration block. So at the same time that we're setting up our routes, we're also able to specify which of those routes should be whitelisted. I have seen some people prefer to handle this all within the same definition, where the route itself contains a data block or a flag that says whitelisted or not. That, of course, is entirely up to you, but for the purposes of this, I find that being able to just add your own expressions is the most straightforward. And then finally, all we've done here in our run block, after we've initialized the API itself, is we check to see whether or not there's a user. This is certainly not a requirement, but it is a practice I highly encourage. Your users, most of them probably aren't developers. They're not thinking through the fact that you've got all your state initialized, and when they click the link, the browser didn't actually reload the page. And so they have a tendency to forget or out of habit, or if something doesn't go the way they think it should, they're going to push that F5 button and refresh. And so I like to check wherever I am. The first thing I do is just check and see whether or not that user is loaded. That makes sure whether they landed on my landing page or some deeply nested link. I know immediately, and there's no delay in the rest of their user experience if they just forgot or bookmarked it perhaps even. At this point, I invite you to, if you haven't been following along already, actually do run that grunt serve command. Make sure you have this final route whitelisting tag enabled. And then go ahead and click that login link. This will allow you to create an individual user and will take you to the app itself. The app, of course, is entirely a blank page that says hello and what your username is. So it's very simple at this point. But you can check out your cookies if you want inside the user console log, or dive through any others. Just hit that refresh button like we just talked about to validate that when you're at /app, you are in fact going on. Now, one of the things I want to talk about here a little bit, pause for a moment, is that our request interceptor, I'm actually going to pull this back up again so you can see exactly where I'm about to mention here. Our request interceptor is not, in fact, rejecting unauthorized requests at the outset. It is, in fact, returning this defer until authorized. Obviously, that's a custom method that's not built in, but it's pretty straightforward with the Q library. So instead of, again, rejecting every request that a user makes, we instead allow it to just hang. It sits in the callback waiting until we send that event that says, hey, a user has authenticated by now. You are now free to flush all these requests through. I find that's particularly helpful for the user experience and for your own development process. You no longer have to check and say, hey, when the user loaded the page, did the authentication loading the user come through first, or do I need to recall a request that got rejected because we hadn't received confirmation yet that that user was in fact authenticated? By using the defer policy instead, what it lets us do is just hold on to that config, and the moment we know that the user has in fact been authenticated, or if they never do, it will sit in limbo until the user closes the app. At the moment we know the user has been authenticated, we can go ahead and flush those requests through, load the template, make any necessary calls we need to load the rest of the data for the user's account, providing both a better experience for your end user as well as making sure that you don't have to do any sort of extra additional checks, validating that your calls did in fact happen in the right order, because we all know the greatest and worst thing about JavaScript is the fact that it's asynchronous, and it's really easy to get lost as far as what has happened when. Returning back to this, again, feel free to refresh the page to see how the user has in fact been persisted across loads. And also, you're welcome to go back to the slash. You'll note that the link that used to say login is now aware of the fact that a user has been authenticated, and it just says go to app. And this is another advantage of loading that user at the very beginning of the run, is that even routes that are technically whitelisted still make sure they get that user information if they want to conditionally display certain blocks or different permissionable actions based on that. Of course, however, just being able to keep track of a user is really not all that exciting. It's not that valid. The biggest thing we care about is making sure that user data doesn't get sent to people that it shouldn't be. So if you want to test this out, I invite you to go ahead and either clear your cookies for the local host or open up a new incognito browser, but try going just straight to that /app URL. This is the route that wasn't whitelisted, and therefore from the perspective of our interceptor, it's not authorized, it's blacklisted, nothing should be allowed to go through. And if you look at your network tab, you'll see that that in fact is the case. Nothing will get passed through, 0 API requests outside of that one single check to see whether or not there is a user loaded. Again, this is helpful for two reasons. One is that it makes sure that the user experience is exactly what it should be. Obviously, we don't want to just give our users a blank page if they land on the wrong place. But we also don't want to slow down the loading by making a bunch of other requests and waiting for the browser to finish finding out that all of those are unauthorized before we move on to providing a modal to allow them to log in, or downloading some other template, or perhaps even redirecting them to the login page. Additionally, your back-end developers will love you for this. This is highly important because as your app starts to go from 10 people to hundreds to thousands or even tens of thousands of people all there at the same time, a vast majority of them are going to have bookmarked /app, and they're going to land there and they won't be authenticated. And you don't want to flood your back-end with a bunch of unauthenticated requests if you already know that the user, in fact, isn't authenticated, and so there's no value in making that request in the first place. Authentication from the back-end perspective is often one of the most intensive things because it requires new database queries and hashing and things like that. So if we can limit those requests just by doing that one simple step of holding these requests until the user is authenticated and we know it, we've just made our app 2, 3, 4, 5 times more scalable with a pretty simple check that both gave our users a better experience, gave us as front-end developers an easier time putting it all together, and gave our back-end guys a little bit of stress relief. Finally, the way these all again work together is we've taken an HTTP interceptor That allows us to ensure our requests send cookies, but only send cookies when they're supposed to. We use those values and those services to do the checks to make sure that those cookies go through to our API and no other API. Again, it also allowed us to do things like bypassing authentication for very specific routes, etc. And then, of course, block, or in this case, defer any requests that aren't whitelisted, that aren't ready for sending them through until the user has, in fact, authenticated themselves. Finally, we have a provider that allows us to do easy whitelisting. You can set it up at the exact same time you're setting up your routes to make sure that the responsibility of each part of the code is clearly understood and well pieced together. And then finally, we have a service that maintains that authentication state throughout the navigation of the app. This isn't nested into a scope variable on your controller or directive. It's something that will persist no matter where the user navigates, as long as your Angular app is still running and controlling all those individual navigations. At this point, I want to open it up a little bit to questions. I've provided some links here based on what I used both in my own authentication apps as well as putting this together that I found particularly helpful. Again, I've also listed here the various repos that might be helpful or that people value if you want to look at the code again in context, or if you want to check out even the API. This is a simple API that's running on Google App Engine using Go to handle both namespaced accounts like we talked about with the prompt at the very beginning, and then individual user creation and session storage. So let's take a look at if there's any outstanding questions. Again, as Yasmina mentioned at the beginning, be sure to prepend those into the chat room with a queue. That way the team knows to go ahead and handle those in the appropriate box. Great, thanks, Mitch. The question here is, how do you handle testing with something like QUnit? For most testing that I've done is, in this case, we're going to talk more on the front end as far as both Karma or something like Protractor is involved. This testing in a unit case, this is, again, a really valuable time to have used a factory in putting that together, because what it means is you can check that does my request go through if isAuthorized returns true, or if authorized returns false. And because we've used a factory, you can simply mock that factory up and then use a decorator to handle that. I actually, let me pull up the URLs here in a moment, just put together a post on this exact question of using decorators within your test to mock some of these factories. That way, for example, we have the user auth provider. When you're going through and testing to make sure that your request interceptor, in this case, does in fact block any request until a user has authenticated, you can simply mock that user auth provider to say isAuthorized is false. Use the mock HTTP backend to go ahead and flush that through, and you should see that it never in fact goes through. And then test and see how that could be. And let me pull up a quick code example for you, and I'm going to switch over to screen share. Hopefully the audio will still maintain pretty well so you can see what this is doing. We're not testing a interceptor in this exact method, but it does provide a way of demonstrating how you might use a mocked provider, which is the whole point of doing these services in the first place, or an extremely helpful reason of doing these. Well, give me a second to load up screen share, and hopefully that will be a little more helpful for you. So here's an example of how services and factories make not only our lives in the actual initial app code easier, but they also make our lives easier within the testing situation as well. In this case, the module in question relies on Angular's built-in $timeout. That's an extremely helpful thing during your actual app, but it tends to make testing really difficult because it's all asynchronous. So what I've used here is the decorator method on provide to replace that with my own synchronous function executor. In the same way, we might replace this with, for example, user auth, and return just a standard object. And we can now set this question to say, is authorized is a function, and it returns false. So here we have an example of why, again, these factories are so much more helpful than hard-coding all of this into either your Interceptor or some other nested method. These we can now use both in isAuthorized and perhaps even a whitelisted method to return the values that are exactly what we want for each test. So we can now write a test that says, for example, one route is in fact whitelisted, one route is not, or the user is or is not logged in. And we can test all of those variations without being dependent on making additional API calls or trying to store all that state somewhere else. We can just update the service that our Interceptor depends on to validate that it responds in the correct way. Hopefully that's helpful. I will push out a URL here at the end on decorators and how you might use them in more detail in your test. That hopefully that can be helpful as well. Let's go ahead and move on to the next question here. And he's talking about cores here, cross-origin resource sharing. Perhaps the simultaneously most amazing new feature of API/front-end single-page application development, and also one of the most confusing, is definitely cores. It's something that confuses a lot of people and is very easy to struggle with. Cores is a way of telling other servers that the application that you have built, that you are requesting data from, is allowed to in fact get and send data. For security reasons, most servers won't let you do this unless you've explicitly specified it. That way other apps can't flog you down or slow you down or try to hack you with a series of requests designed to get into your app. Cores, however, requires a lot of different configurations. So let's actually, I'll pull up an example of how the server for this actual demo is set up, and walk you through some of the headers that are necessary for this, and hopefully that will be a little bit more helpful. So let's switch back over to screen share here. And you can see this is the Go API as it's built, and we have a standard cores handler in here that does a couple different things. The first thing it does is it specifies access controls allowed on the origin. You have to specify in cores which origins are allowed for a request. Most commonly during development, I find myself just using star. However, it's very important to note if you're going to allow credentials, as we've done here for cookie-based authentication, the core standard does not allow you to also say any app can request or make a cross-origin request. So instead, you have to specify exactly which origins are whitelisted. This is a development wrapper that I use when I'm trying to just prototype or put together an app really quickly. So I've relied on just grabbing the origin that the request header actually sets that serves to function as if it was star, except follows the standards. And of course, as you move this into production, you're going to want to actually hard code and specify based on your environment which origins there are. The other thing is you have to be specifying which methods and headers exactly are allowed. Not only can you just say, yes, this domain, example.com, can make a request to my server, but you also have to say, example.com can make a request with a get and a post but perhaps not a put, not a delete, not any of these other methods. The same goes for headers. We discussed the idea or the fact that we were using header-based authentication at times. If you're going to do that, you need to make sure you've whitelisted those headers explicitly within this response. Otherwise, when your browser first tries to make that request, it'll get instantly rejected and your authentication check on the API will never even know about it. The final thing is for cookies, as we mentioned, you can't just specify with credentials on the browser side AJAX request. You also have to tell the CORS handler that it is allowed to both receive credentials and then to send them back. Otherwise, they'll just be stripped off or possibly rejected depending on your browser configuration. One thing that I struggled with a lot when I first started doing CORS development was trying to figure out what all these options requests were that kept showing up in my server log. And so something that's not obviously broadcast out, but if you dig a little bit, you can find out about is that when you're sending any what the browser considers to be a non-standard AJAX request across domains, it considers standard to mean GET. All you're trying to do is retrieve data, and that's it. If you're doing anything else, whether it's a post or a put or anything with some sort of differing config, it first does what's called a pre-flighted request. And this is this options request that you likely have seen if you're struggling with this, flooding your server log. It contains no data. It contains nothing else. But what it does have is the exact same headers and HTTP method signature of the request that you're trying to make. So if we, for example, were going to send a post request with some form encoded values of name equals Alex, this options request would not have the form encoded values, but it would tell our server that the content type was text form encoded. It would tell the server that it was a post, and it would also tell it what kind of headers it was trying to send with it. That allows the server to very quickly and very easily respond back to the browser with either that type of request is allowed or that type is not. And so it's important when you're putting together a CORS API side handler that you make sure that you look for these options type requests and you just flush them straight through, but only after you've applied the correct CORS-based headers to tell the browser that these requests are in fact going to be allowed. As far as a resource goes, the link here that I've specified, and I'll pull this slide back up once the screen share is done, with Mozilla Developer Network is a phenomenal resource. It's what I rely on almost entirely when I'm doing any sort of CORS development because they specify every type of access control header you can return, what can be sent along, and the way those interact. For example, in this case of allow credentials, I learned as I was putting this together that allow origin with star couldn't be used with allow credentials true. So that would be the resource I would recommend most highly for getting started with any sort of CORS development. We have two questions here talking about third-party authentication services, one about Mozilla Persona and another about using some sort of OAuth such as Facebook, Google, any other third-party authentication or user profile provider. This is something where you would be able to plug that in directly into your service, the isAuthorized check. Let's go ahead and pull up the full version of that so you can see exactly what I'm talking about here. You can see this is inside our user authentication service, and we have isAuthorized is a very simple method in this case. This is something that all it does is looking for a flag that gets set when we've successfully loaded a user. However, we might also, if in the case of a no-auth provider such as Google, either set that flag based on the response that we get from our front-end OAuth connection. Facebook provides a very good JavaScript SDK for handling all of that with some callbacks to let you know, yes, the user said you can go ahead. And so at that point, when we get that callback, we can set our own cookie if we want, pass it on to our backend API server that says, for example, this is the Facebook token for this user, and our API can now use that, and we can also rely on it on the front end for our authentication checks. If it's something more complicated where you need your actual server to handle the callback, the OAuth callback, and do some processing and then send it back to you, you might have to rely on either something such as polling or even a sockets if you're lucky enough to be working with a system that supports all those and you don't need to worry about older versions of Internet Explorer. Sockets are a great way to have your server send an info right back to you that says, hey, the user just gave us the all clear to have access to their Facebook account. Here's the session information you need to know about, as well as some basic user data, such as their name and what they care about. So in answer to the question of how would we use OAuth within this system, these two methods basically are exactly where that's going to sit. It's the authentication check as well as any sort of internal method that you need to authorize that user. And again, that could vary so much based on each web app as you go forward. In response to the persona itself, I haven't used them explicitly very much. I've tinkered around with a little bit on the front end. Unfortunately, I haven't had a chance to get back to them since they kind of came out and released a standardized version. But it does look very promising. I'm certainly interested in the idea of just one authentication user identity service that covers pretty much everything. Okay, here's another question on what about JWT or JSON Web Token? Would that be more of a kind of header authentication? Yes, that's exactly what JWT does. Is it passes that web token via authentication. I'm not using that explicitly in the MVD.js, but if we take a look at how that one is plugged together, you can see, let's go back to screen share here. Each of these headers, we have basically one set of headers. We have a session that would be corresponding to that JWT token, or I'm sorry, JSON Web Token that we would send back and forth. It could also be a session key, or sometimes you need the full account and key, often on an initial authentication call. So for something like JWT, depending on where you're plugging that into your service, it could be a matter of your backend server generating that token on a page load and just sending it right out with the web app. Or it could be something where the first call you make to the API is basically nothing more than, can I please have a token? Give me this info and use that for all future calls. So this is how you might handle it via the headers. This method set headers is exactly that. The request interceptor takes a config header block and appends the appropriate headers. So in the case of JWT, this could instead be XJWT. If you're not familiar, X- is the most common custom header prepend. That way you don't have to worry about some new header becoming a standard and overriding something you've been using for forever. X- will always be reserved for custom. And so again, if you want to use a session or some sort of JSON token, this is where you would apply it. And then all your interceptor has to do is, again, you can see here we're checking to make sure that we're not going to send our authentication info out to a different API, an API that we don't own. And then as long as that's the case, we go ahead and append those headers onto our existing set of headers to handle the token-based authentication within a header request. See my question? How would you go about securing cookies, making sure they can't be reused or picked up by a man in the middle? HTTPS, honestly. When you're working with front-end code, there's only so much security you really have access to, and the most and the best, assuming you have recovered from the Heartbleed issue of a couple months ago, is still relying on HTTPS-based requests for all of those. That's the only real obfuscation we have for man-in-the-middle type attacks. As far as storing them on a local browser within the person's computer, that really is up to you. There are methods of just asking the user, as you've probably done anytime you log into a webmail, where it just asks, are you on a public computer or a private computer? That's one way of choosing what type of cookie or what information you want to store in their cookie. Another thing is some sort of obfuscated where what gets passed along is actually a hashed version and it gets compared. So that's another way of making sure that that info is protected as much as possible. Let's see, we have another question on what would you do to also check an ASP auth cookie. Truthfully, most of the time you don't have to. The advantage of with credentials is that the browser will just automatically send the cookies with your request. So if your backend is Go, PHP, Ruby, ASP.NET, it doesn't really matter, and your front end doesn't have to worry about it because those cookies just get sent with the request. And if your response includes a header that says set cookie, it will do exactly that. You don't have to worry about it. If it's something where you need access to the cookie itself, I recommend Angular's $cookies service. But of course, at that point, you have to know the exact name of the cookie you're looking for. But from the browser perspective, it doesn't matter whether your cookie was set by ASP or any other type of service. From the front end, they all look exactly the same. We have one more here on how to integrate Firebase SimpleAuth. Unfortunately, I haven't had too much experience with Firebase itself beyond some tinkering apps that didn't require any sort of authentication. However, my understanding of the way they plug it together is that it would be very similar to the questions of OAuth. You're going to have two basic requests, or two basic methods, which an authorized that triggers whatever the Firebase built-in authorized policy is. If that requires a full-on pop-up, if it's something that can happen entirely behind the scenes, or some sort of in-between modal, that's really up to how you're going to plug it in. But once you've done that, you almost certainly can satisfy it with either setting some custom headers on your request going forward, or you can handle it by using, again, those cookies and with credentials to pass those cookies back to Firebase on each request. As far as Firebase's internal library goes, I'm not confident on how they've implemented their authentication. I would expect that they provide a method similar to isAuthorized that you can check and see whether or not your user is initialized, or possibly you may have to do some actual data checking based on the user objects available to you for use within your application. We're coming up here at the end, so I'll take just one or two more questions. And then I do invite you all to interface either on the blog. As I mentioned, I've put out some articles on decorators and how those are helpful in testing services. Or again, hit me up on Twitter or Google+. All those links will be available here at the end. It looks like that actually is going to be pretty much all of the questions that we have right now. So it looks like Yasmina has just thrown up the link for the book with a chance to get 50% off. Otherwise, please do leave comments either on my blog, or there's a link to email me there directly if you have further questions. I'd be happy to set up some time to talk with you, whether it's via Hangout or just email correspondence. Thank you all very much for your time. I've appreciated this greatly, and I hope you all enjoyed it as well.